Welcome to Divergent 3D. What we do is create a new system for designing, engineering, manufacturing, and assembling cars. It's based on a new technology base, or something a lot of people call 3D printing. Print, assemble, drive. Hi, Cars TV. I'm Kevin Zinger, the CEO of Divergent Technologies. We're here in LA where we have our mechanical engineering team and a reference factory that we use to build vehicles. What we do is create a new system for designing, engineering, manufacturing, and assembling cars. It's based on a new technology base that incorporates additive manufacturing, or something that a lot of people call 3D printing. Compute optimized structure, send data to printer, print, assemble, drive. Earlier I had co-founded an electric car and battery manufacturing company, and the manufacturing of both the vehicle and the battery system took place in China. And two things happened, really. We ended up spending more money on the metal bashing part of creating and manufacturing that vehicle than we did on all of the groundbreaking technology on the battery side and battery management system and thermal management system side to create a full battery system for a car. And the second thing was around 2010, when we started operating our large-scale battery manufacturing facility over there. The US National Academy of Sciences came out with a life cycle analysis of vehicles, and that life cycle analysis showed that vehicle manufacturing had a far greater impact on the environment than tailpipe exhaust. And so I went, aha, I think I'm saving the world as a technologist, and I'm spending more on the manufacturing part of the vehicle than on the technology, number one. So it's pretty clear in this industry the manufacturing piece is broken economically. From an environmental standpoint, it's also very clear that the drivetrain is actually less important than the entire manufacturing cycle for the vehicle. And those two things led me to say, you know what? Let's sit down with a clean sheet of paper, see if there is a new technology base. They were, and this company is the result. So I grew up in Cleveland, Ohio. And I was the youngest of five, very working class family. One of my brothers was an auto mechanic. Both of my brothers street raced. One of them also drag raced. So at a very early age, I was working on cars for them. I was considerably younger, so I was their indentured servant, probably from the age of 8 years old or so. My first hot rod was a 1962 Ford Falcon. I had put a V8 in it with a 3-speed manual transmission, and back then things were very simple. Electronics were very simple. You had an engine puller, you pulled out the engine, you went to the junkyard, you found a larger engine, you paid $75 for it, your car cost $200, and you put it together and away you went. The auto industry right now is under a couple of different pressures. Those pressures include looking and saying, will we be completely disrupted by a future of autonomous EVs and mobility services with a totally different business model? So in some models, you don't own a car, you call for a car on your phone, and the car arrives without a driver, and it's in a fleet that somebody owns. So with those pressures, people are looking at, and what I'm saying on top of the benefits that you're talking about is, if you're going to move to those type of vehicles, you better be the most efficient manufacturer in the world. Those fleet cars are going to be in lower volumes. Right now, the traditional model doesn't allow you to make money on lower volume manufacturing, and it's really volumes under 75,000 units a year. So if California or say LA says, we're going to have mobility services fleet for LA this is the type of vehicle that we want to have, you're going to have to be able to quickly design, engineer that. And my bet is they're going to follow some of the cities in China and say it's going to need to be manufactured locally. And when you take those factors, those requirements, that disruption, and you say, hey, does that fit traditional manufacturing of autos? Hell no. There's a fundamental misfit there. And what we've done is actually architected for those circumstances. So that's there, that's helping us. At the same time, I'll paraphrase Machiavelli when he was talking about what happens when somebody comes into power and they want to create a new order that's going to be more beneficial. Whoever tries to create that new order, they have the incumbents and they have the people sometimes that benefit the most who are still lukewarm because they have not yet seen the benefits. So, in the startup world, you've got to be tough, you've got to be persistent, you've got to keep your powder dry, and you better have a very, very, very compelling solution, which we think we have. When that car gets driven in downtown LA or San Francisco, like literally without people knowing it's a 3D printed car, it stops traffic. The color came from an orchid that was on our kitchen table, and I was sitting there one morning and the sun was shining through in Santa Monica, and I'm like, that is such a unique color and I need a unique color. It's going to take many, many tries to get this thing right.
Closed captioning provided by
Hi, I'm Kevin Zinger, the CEO of Divergent Technologies. Welcome to the Divergent factory here in LA. This car, its creation came from a couple of objectives that I had. So I had gotten to the point in 2014 and I was funding the company myself, where I said, I think that from a cost performance standpoint, you actually now can start to build the structures that I'm talking about. Time to do the first example of that, the first technology demonstrator. And so I said, I want to build a car that inspires me and inspires the people around me and is cool. I want to inspire the general public when they see it. I want to inspire investors, and I want to catch car companies' attention. And I want to do something that's a product that's just cool and badass. I'd say on the safety side, you're putting the vehicle through the same process you'd put any other vehicle through, the same validation. And when you're looking at the entire structure of a vehicle, if you can take out half of that weight, and I don't mean of the overall car, but that structure, so then you can start to lightweight everything around it, then you're talking about real change. You want to have something that people look at and go, wow. When that car gets driven in downtown LA or San Francisco, like literally without people knowing it's a 3D printed car, it stops traffic. I also figured out a pretty cool color for it. The color came from an orchid that was on our kitchen table, and I was sitting there one morning and the sun was shining through in Santa Monica, and I'm like, that is such a unique color and I need a unique color if I'm going to really evoke the animal spirits. And this thing is like nature and beauty together. Now I'm going to go drive people working with me crazy because they're going to think this is a non-traditional color and it's going to take many, many tries to get this thing right. But we got it right, and so that's a color I call liquid orchid. I love it. It weighs, dry weight's 1,388 pounds. I put a Mitsubishi Evo 10 motor, AMS board, and stroked it to 2.8 liter. It can be green, so it has both a set of CNG, compressed natural gas injectors, and regular gasoline injectors. So it can be very green, but at the same time put out 720 horsepower. So you have power to weight that's off the hook, that's better than a Formula One car. As you can see, it's got a license plate on the back and can create a lot of fun for somebody who's into it. This is the Divergent Blade supercar. It has a 3D printed chassis. So the frame of this incorporates 3D metal printing. And that 3D printed chassis has the strength and torsional stiffness of a true supercar. On top of that 3D printed structure, we have a carbon fiber body. So the body using this building process, because it's not structural, can be sculpted in almost any shape because you don't have to worry about engineering crash structure into the body. This car itself is sort of my idea of, Cleveland hot rodding meets Silicon Valley technology. It's a two-seater. You sit in line. The driver sits in the middle of the car, which is the most fun way to drive, in my humble opinion. And then the passenger sits in back of the driver, and that also allows you to minimize frontal surface area for better aerodynamics. So once again, this is 3D printed structure with carbon fiber, gorgeous body on top of it. Pop over here, I'll show you. Inside, you can see part of the structure. The silver parts of the structure are 3D metal printed connectors. So back here is where the motor is. It's a mid-engine vehicle. Has a Mitsubishi Evo 10 motor, AMS bored and stroked it to 2.4 liter. With the turbocharger boost up, it generates about 720 horsepower. The drivetrain is connected to a Hollinger 6-speed sequential gearbox, racing gearbox, and the thing can boogie and is a lot of fun. I would say that longer-term vision of sort of harmony between people, their work, their local community, what they create, and the environment, is the goal. That's how nature works in its best way with evolution. That's why the company's called Divergent.
Closed captioning provided by
The reason why I'm doing this, in my 50s after having had other technology companies, and whenever you start a company, it's a brutal amount of work for years on end with a brutal amount of risk, is because, going back to what I said on the environmental side, it took us 115 years to build 2 billion vehicles. Most of the environmental damage coming from manufacturing. With a world that's gone from 2 billion people in 1925 to 8 billion people in 2025 and going to over 10 billion in 2050, we're in the next 35 years going to build over 4 billion additional vehicles. On average, the vehicles being built today are 50% heavier. So that would be like building 6 billion vehicles, tripling the number of vehicles it took to build in 115 years in 35 years, with heavier vehicles using more fuel. I looked at that and said, we have to do something which is much more efficient not only from a capital efficiency standpoint, but something that's much more material and energy efficient. And this process drives the material and energy impact on the environment when you look across the life cycle of the vehicle down by over 50%. So you have much cleaner vehicles over their life cycle. And because there's lower cost to enter or to create vehicles over time, you'll also have much more innovation. We think that this is really a system for driving efficiency, sustainability, and harmony of products with the environment. This is the structure of the blade. The silver parts are 3D printed aluminum. These more rose-colored parts are 3D printed titanium. These shapes look organic, but we weren't trying to copy nature. We were simply optimizing the parts, and because nature competes for material and energy, when you're optimizing, things look very organic, like this. The 3D printed parts of the vehicle, the suspension, the connecting pieces, are used to connect standardized materials. Here is an aluminum extrusion, high performance, low cost. The rest of these materials, primarily the carbon fiber materials, come from the aerospace industry. This is, unlike where you mine materials and then you throw away those materials when you've built something, here at the end life of these parts, like this suspension arm or any of these parts, you can simply take the 3D metal parts, put them back through gas atomization, turn them back into powder, and turn them into a new part. We need to think about how most efficiently to use our material and energy. This is simply aluminum. You atomize it, it's no different. You turn it back into a powder and you rebuild a part.
Why would you do it any other way?
Habit. I think that the auto industry, unlike some of the industries where you've seen all of the incumbents go away, there was the transition to metal and rivets, all the incumbents went away. When you went from propeller motors to jets, the incumbents went away. Look at what's happening with the print industry, right? Incumbents going away. Look what happened to companies that made film. At one point, the moment before the death knell for all of those companies, they had higher sales than ever before of film, right? More people were taking photos than ever before. Then you have a digital camera. The auto industry at least sees what is happening. And they've got a couple reference points now, and I think they're moving much faster than I would have expected even a year ago. So when I look at this company, say, a machine that can make other machines, if you bring down the capital cost of that creation, right? People can then, in a small team, access that creative machine and have lots of information about what's the best machines to create and sell within the context of their environment. That's how nature works in its best way with evolution. That's why the company's called Divergent, because it's after Divergent evolution, which was a term coined by Darwin. My idea is, over time, democratize access to those creation assets, localize those creation assets, have people create things that are meaningful for themselves and the community. I would say that longer-term vision of sort of harmony between people, their work, their local community, what they create, and the environment, is the goal. And I jokingly call it wildflower innovation, where, I'm not dominating, but lots of things are blossoming and creating and interacting in harmony. That sounds a lot cooler to me.
Closed captioning provided by